Great. So type of matter, just a little clue, how to figure out, is it a compound, is it a mixture, is it an element, whatever. You guys got a flow chart in class. So you got a yellow sheet of paper. Yeah. I gave them 2 flow chart options too. There's 2 ways to read it, you know.
Different learners.
Ooh, yeah, depends which one you want.
Right.
So here's the first thing to ask. Is there multiple phases? If there are multiple phases, as in it looks different in different places. Actually, yeah. So see that chocolate chip cookie?
It is now Mrs. Dominiac's head. Different things.
Yeah. So, did each little piece that hit your mouth taste a little different? Yeah. You're like, oh, there's a little chocolate bit.
Yeah, chocolate bit.
There's a little cookie bit. Right. So it has different phases. There's the chocolate chip phase, and then there's the cookie phase.
Yeah.
Excellent. So if it has different phases, it's heterogeneous mixture.
Hetero.
So here's an example. Oil and water. They do not mix, so it's not a solution exactly. It has 2 phases. I've got the yellow, the water.
Same example. Boom.
Okay. How about how to determine, I don't know what to do with our picture there. Okay.
Yeah, you can put it anywhere.
Yeah. Determine if it's an element, compound, or homogeneous mixture. Or how do you say it again? You say?
Homogeneous.
Homogeneous.
Right. Because I went to school in the north, and you went to school in the south.
I don't know if it's a southern thing or the fact that none of my teachers came from America, so they have very thick accents. You know what I mean? Like, I had all sorts of accents in college, which was really cool, but sometimes I don't know how to pronounce things.
Yeah. Mrs. Silverman also has a bunch of different accents based on varying degrees of tiredness.
Awesome.
Yeah.
Okay. So if the substance looks the same throughout, it's going to be one of these things.
I was looking for something. But you have milk. I was going to say milk. Milk is homogenized. Right.
So so if there's one phase, think if are there multiple varieties or is there just one type? Like, how many options are there? So for multiple types, it's going to be homogeneous. Is that how you say it?
Yeah, homogeneous, whatever.
Mixture. So for example, milk.
Milk. La lèche.
Right, what?
That's French.
Okay, that's all fancy here. So you can get skim milk.
Skim milk.
You have 1%.
1%.
2%.
Yeah.
And whole.
Yeah.
What do you get? Do you drink milk?
I'm a skim milk guy. I drank a gallon of milk a day.
Stop.
In my high school career. And so I've had doctors tell me I have like
You're so tall.
No, big bones. I'm medically proven to have big bones. That's no joke. Seriously. It's the thing. You laugh. You want to know what else is a confusing thing? But like gasoline. When you go to the store or when you go to the gas station and you buy gasoline is also one of those things that is definitely a homogeneous or homogeneous mixture.
Yes.
Because you can choose whether you want the 89, the 91, or the 93, or the 87, 91, whatever. I forget what all the ratings are. Yes. But because there's different varieties of it, that implies that it's a homogeneous mixture.
The first time that I went to a gas station in New Jersey with my husband, I didn't really understand, like, what to say, and I just said, I want the 87, and he was like, nobody says that.
Right.
But I thought you were just supposed to tell what type, like, what octane level I wanted, so.
Right. Well, that makes sense.
It makes sense. The guy knew what I meant, but I got
makes sense.
Made fun of. All right, so that's going to be a mixture, because there's different varieties. It's not ever going to be really a pure substance, because it's a mixture.
And I will say that in my experience, it's always hard to tell the difference between a homogeneous mixture and a compound. Those are because the elements. I know that we're probably going to get to those things, but like the elements are tough or easy because they're on the periodic tables. They're more straightforward.
Right.
Just 118. Sure. And then if it's chunky and have different parts to it that you can see, that's a heterogeneous mixture. But it's always the homogeneous versus the compounds. And that's a very good way when you know that there's different types of the same thing. That's a very good way of explaining it.
Yes.
Yeah, good.
The other way is if you have internet, you can look it up. No, not the answer.
The other way.
If there's no chemical formula, it's a mixture.
Yeah, or if there's like ingredients.
Ooh.
I always think of like all food, no matter what, is not no matter what, but in general, food, like an apple. An apple is a mixture because it's got like skin and then the meat of the apple and then there's the seeds and those little things.
That's going to be a heterogeneous mixture.
It'll be heterogeneous, but still most foods are so like some sort of mixture.
A brownie, when you eat it, is going to be the same all the way through, but it's not a compound.
Right.
Because
it's
still has
got a whole
sugar
bunch of different parts in
so
it. Yeah.
Yeah.
So
All
that's cool. That's a good way of explaining it. I love it.
Thanks. High five to us.
We just made
Boom.
We just made chemistry, Tommy.
All right. So again, if it's one phase, are there multiple varieties or just one is still the question. So if there's only one type available, it's either an element or a compound.
Yeah.
Right. So
Right.
if that's it. If
Right.
you decided it's not a mixture.
Like sodium chloride. Boom.
Mm-hmm.
Sodium chloride. Is it just one thing? Yeah, that's
Right.
the only way that it can go. Water.
That's actually...
Is that sugar?
Sucrose, yeah.
Oh, sucrose.
Well, it could be...
I don't know.
Yeah, anyways. So look on the periodic table is my clue. Like, if it's on the periodic table, like if it's zinc, Zn, you know it's an element because it's the periodic table of elements.
Right.
So, great. If it's not there and you know it's not a mixture, it's going to be a compound. Like sucrose. If you look on the periodic table, no matter how long you stare at it,
right.
Sucrose will never be there.
Right. And actually, that's a question that I'll ask my students. If they say that sucrose is an element,
right.
I'll look at them and I'll say,
prove it.
Where is it on the periodic table?
Right.
I'm pointing that way because that's where my periodic table is right now. But and then they'll be like, I don't know. But that's the thing. So
right.
yeah. So
the other thing to look for is
I'll get out of the picture now. So
chemical formula. So like sodium hydroxide, NaOH. So anytime you see a capital letter, that's the next element. So Na is sodium. I've got an oxygen. I've got a hydrogen. Since there is more than one element and there's a formula, then you know that this is a compound.
Compound.
Boom. All right. So actually, that's it for this little lesson.
Little lesson.
Hope you enjoyed.